When Nvidia CEO Jensen Huang announced at GTC this week that the company would produce a CPU alongside the current GPU and DPU chips, the tech industry pundits lost their mind. To hear them tell it, this new Grace processor would see Nvidia challenging Intel and AMD in the server and the cloud, with ARM finally putting an end to x86 dominance. But these hot takes are way off base and miss the point that Nvidia was trying to make. Grace is about filling the pipes of the company's ever more powerful GPUs by pairing it with low-latency memory, thus the name. Nvidia Grace does for GPU what Bluefield does for the network interface. I'm Stephen Foskett, and this is the Gestalt IT Checksum. At GTC this week, Nvidia announced the third generation of their Bluefield DPU. This 400 gigabit network interface has 16 ARM A78 CPU cores and plenty of DDR5 memory. The DPU can natively run enterprise software like VMware NSX, Fortinet and Guardicore firewalls, and NetApp and Weka storage processing. This frees up CPU resources for production applications. One of the many things Commodore Grace Hopper was known for was her famous story illustrating the length of a nanosecond. The issue then was latency and how to explain to an admiral how distance impacts network performance. Latency is still the ultimate hurdle to performance, and it strangles high-throughput processors like those used in GPUs. Nvidia knows how to keep their processors busy. They write software libraries after all, and these go hand in hand with their famous chips. But no amount of software or hardware can make up for a lack of bandwidth between the data and the processor. Although PCI Express is fast, it can't feed data quick enough to satisfy the latest Nvidia Ampere GPUs. Placing a GPU on a PCIe expansion card limits total memory to GPU bandwidth to just 64 gigabytes per second. But native GPU memory can deliver a whopping 8,000 gigabytes per second. This has limited the practical size of machine learning models and thus the questions that can be answered by AI. Now let's consider Grace, Nvidia's new CPU platform. Nvidia named this CPU after Grace Hopper for a reason, and it has everything to do with latency. On the face of it, one might think that Nvidia Grace is a new server architecture based on ARM and NVLink, but this is way off the mark. Instead, think of Grace as an offload engine for the GPU, analogous to the way a DPU handles networking workloads. Is there really any difference between placing some ARM cores and RAM on a GPU card instead of on a network card? But Grace is also designed to address a critical limitation in modern computer architecture and help extract maximum benefit from Nvidia's signature GPUs. Grace will use advanced ARM Neoverse CPU cores and LPDDR5X memory to provide general-purpose compute literally next to the next-generation Ampere GPU cores. And these Grace CPUs will have NVLink built right on the chip, enabling incredible throughput of over 2,000 gigabytes per second. AI applications will be able to expand beyond the GPU memory without taking a latency hit of a trip all the way across the PCIe bus to the main system memory. And Grace cards will be able to interconnect with NVLink just like GPUs in today's Nvidia DGX and EGX systems. Back in 2014, IBM, Nvidia, and Mellanox collaborated on the development of a new supercomputer for the United States Department of Energy. The Summit and Sierra supercomputers used Nvidia's proprietary NVLink protocol to connect Nvidia's Tesla GPU to IBM's Power 9 CPUs, massively improving throughput. And the nodes used Mellanox InfiniBand with a state-of-the-art, for the time, offload capability. If this sounds familiar, it should. Nvidia is essentially delivering a supercomputer architecture to the data center, with offload engines for the NIC and the GPU. Bluefield and Grace reduce the overhead on the server CPU and help to move the data center to a disaggregated supercomputer architecture. As I discussed in the Checksum editorial relating to the recent Intel Ice Lake Xeon Scalable processor launch, The enterprise server is on the verge of a massive disruption. Compute Express Link, or CXL, enables more flexible connectivity between CPUs, memory, storage, and I/O devices. Thanks to CXL, the servers of 2023 will be more flexible and expandable than ever, enabling rack-scale architecture and special-purpose configurations. Will Nvidia eventually try to take on Intel and AMD in the server CPU market? It seems pretty likely, especially if the acquisition of ARM goes through. But that's not what Grace is. Grace is all about keeping Nvidia's GPUs fed with data, even as AI models expand in terms of memory and the need for compute resources. Nvidia Grace means that GPUs will have access to general-purpose CPU and additional memory, regardless of the system interconnect. This future-proofs Nvidia GPU even if CXL, disaggregation, and heterogeneous servers take off. And Bluefield is even more compelling in a disaggregated world. Imagine a next-generation server CPU from Intel, AMD, or yes, Nvidia and ARM at the center, with CXL links to memory and I/O complexes all around it. Most of these I/O devices will include CPUs and memory of their own, offloading special tasks like networking, storage, and machine learning processing. This is the future that Nvidia and the rest of the industry are building. Thanks for listening to this Gestalt IT Checksum video. For more like this, please go to gestaltit.com or our YouTube channel, youtube.com/gestaltitvideo. I'm Stephen Foskett, and I would love to hear from you. You can find me on Twitter @sfoskett, or you can reach us on Twitter @gestaltit.